Good morning everyone. Myself Sathish H, Assistant Professor, Department of Mechanical Engineering, MIT Mysore. So today we are going to discuss the course Elements of Mechanical Engineering. In particularly, we start with the module number 1, that is sources of energy, thermodynamics and steam. So in this today's session, we are going to discuss the various topics. The topics are listed out here. First, introduction. In the introduction part, we are going to discuss what is meant by the energy, and then why the energy is important, and what are the different sources of energy as well. And energy can exist in a different forms, so that we are going to discuss under the topic energy and its form. And then one form of energy can be converted into the other form of energy, so that is why the energy can exist in different forms, and then it can be interconverted from one form to the other form. So that we will discuss under energy conversions with examples. And later on we are going to divide the energy based on different criteria. So the one we are going to discuss is renewable and non-renewable energy sources, the differences. And then we are going to discuss about the fossil fuels and classification of the fuels. Fuels are broadly classified as solid fuels, liquid fuels, and then gaseous fuels. And lastly, two topics are calorific value and properties of fuels. So to begin with, coming to the introduction, so we need energy to carry out various activities. So for example, if we take ourselves, like for example human beings, okay, so we do various physical activities, for example walking, running, and then doing other physical activities. For all those things we need energy. So energy we take in the form of the food that helps us to do the various activities. And also the different parts of our body, for example respiratory system, circulatory system, in order to function it also needs energy, that is also taken in the form of food, okay, that will help us to help the organs to perform its functions. So and then if you take the example of your household or your homes, okay, so you will come across various types of energies. For example, if you take your living room, so there is a television, and then telephone, and then as well as a light, okay. So all these appliances doesn't work, okay, without the help of energy. So we need electrical energy in order to perform all these appliances. If you go to the kitchen, you have a refrigerator, okay, and then grinder, okay, and then mixer, for example, and the refrigerator. So those all the appliances, they need basically energy. So we are so much dependent on energy. Without energy we cannot imagine a day. So and also, so if you come out, we have various transport systems. For example, you have a two-wheelers, bikes, mopeds, and then automobiles. Other examples are buses and railway systems and aircrafts, spacecrafts. All these move with the help of energy, okay. So how do they move? Because we have this fuel, petrol or diesel. The chemical energy which is stored in the petrol or diesel, okay, is when it is burnt, it will liberate the heat energy. That heat energy is converted into the mechanical energy that makes the vehicles move, okay. So we look around, everything is energy. So other forms of energy what you can come across in daily life are solar energy, for example, that is the energy from the sun. And then the energy which is stored in the wind, that is called as the wind energy. And then tidal energy, so in the ocean you have the rising and falling of the waves. It gives a form of energy that is called as a tidal energy. Also you have the energy which is stored in the water, that is kinetic energy and potential energy of the water, that we call it as a hydral energy or the water energy. So the energy is important aspect. And then we have a limited source of energies on the earth. For example, we have primary sources of energy, what we call. That means we get directly the energy from those primary sources. And most widely used primary sources of energy today are the coal, petroleum, and natural gas, okay. So there is a problem with using these kinds of energy. The one is they are going to exhaust in certain amount of time. Okay, with the time they are going to deplete or they are going to end. Okay, so that is the main important, because nowadays increasing population, there is a demand for this energy forms is increasing. So the people or the humans are, humankind is looking for some of the alternate sources of energy which will be clean and green. Okay, what do you mean by clean and green is that it doesn't emit any emissions like carbon dioxide and so on. So what are some of the alternate sources of energy if you have on the face of the earth is solar energy, for example, that is energy from the sun, and wind energy. So the blowing wind or the wind stream as the energy in it, okay, that can be harnessed in order to produce electricity. So and then we have energy from the biomass, that is biomass energy, and so on. So this is a brief introduction to the energy. So in order to function, so we can't imagine a day without an electricity or the energy. Okay, so we need energy in our daily basis, and then what we have to make sure is that, so we have to make sure that energy what we are using is a clean and green energy that is sustainable for the long period of time. So and then the second topic what we are going to discuss is energy and its forms. Okay, energy basically exists in two forms. That is, one is the energy which is potential energy and then kinetic energy. What do you mean by the potential energy? Potential energy is because of its position, okay, or configuration. For example, you might have seen children playing with the toys, and then in the toy we have kind of a spring. Okay, so with the muscular energy, if you rotate that energy, the potential energy is stored in that toy, and then when you unroll that or when you unwind that, the movement of the toy happens. Okay, that is an example for this potential energy. Okay, so like that you can take any like numerous examples for potential energy. For example, the water which is stored at a certain height, okay, in the reservoir, okay, that possesses the potential energy. So and then the kinetic energy, kinetic energy is energy possessed by the body due to its motion. Okay, for example, if you are running at a certain speed, okay, you possess that kinetic energy, and then if a car is or a bus is moving at certain high speed, then it possesses the kinetic energy. Or a stone is thrown, okay, that has a speed and it possesses a kinetic energy. And before going to the different forms, okay, this energy, what do you mean by the energy? Okay, so energy is can be stated as it is a capacity to do work. Okay, so this is derived from the a Greek terminology, that is energia. Okay, so that is the term the energy is derived from. What do you mean by capacity to do work is, okay, you might have seen this pressure cooker in your houses. Okay, what happens, you put the raw food into the pressure cooker, and then you put some quantity of the water into it, and then you put, like, you keep it on the stove, and then you start to supply the heat energy to that the water or the contents inside the pressure cooker. Okay, after some times the water starts boiling, and then the weight which is placed over this pressure cooker, okay, starts to lift. Okay, that means we are supplying the heat energy, and then the work is done in terms of a lifting of this dead weight above this pressure cooker. Okay, so that means that energy, that heat energy which is inside this pressure cooker, it is helping to move that dead weight upwards. That means it is doing the work. That is why we can define this as it is a capacity to do the work. Okay, so and some of the other forms of energies are mechanical energy, for example. Okay, bicycle is an example for mechanical energy. With the muscular power, okay, one pedals the bicycle, and then the bicycle starts to move. Okay, that means wheels rotate, and then the bicycle starts to move. That is an example for mechanical energy. And then thermal energy, okay, as I said, the pressure cooker, you can take it as an example where we supply the heat energy to that. Okay, thermal energy is nothing but heat energy. And then chemical energy. Okay, so you might have seen these match sticks. Okay, so what we have in a matchstick, at the end of the matchstick we have this chemical. Okay, so when you strike that matchstick, okay, it starts to ignite, okay, and starts to burn. Okay, so that is the chemical energy stored in that matchstick that helps to give the heat energy. Okay, so when it is when it is when you strike against the matchbox. So and then we have electrical energy. We all know that electrical energy, that is the most useful form of energy that we are using. All our appliances, the light, fan, or a television set, or a refrigerator and grinder, mixer, okay, all those run with the help of an electrical energy. That is the end useful form of energy what we have. So and then nuclear energy. So this is also a very important form of energy. That is the energy which is stored inside the atom. Okay, so by the process of dividing the atom or combining the atom, so you are going to study in the future classes, that is fusion and fission process. So there is an enormous amount of energy stored inside the atom. That energy can be harnessed, and then that can be used in a nuclear power plants. So and then we have seen this the various forms of energy, for example kinetic, and then other forms like mechanical, electrical. So there is an important statement, okay, so that is, it says energy can not be created nor be destroyed. It can only converted from the one form to the other form. Okay, you cannot create the energy, you cannot destroy the energy. So what you can only do is it can be converted from one form of energy to the other form of energy. Okay, interconversion of energy is possible. So for example, we have interconversion of mechanical energy. Okay, so you might have seen, like if you take the two stones and then strike the two stones against each other, okay, what happens here, like by striking the two stones you are doing a mechanical work, and then it produces some kind of a spark, and also you can feel the heat in while holding these stones, and as well as it will produce the sound. That means that mechanical energy is converted into the light as well as a sound as well as the heat energy. Okay, that is a conversion. What we are making is mechanical to the other forms of energy. So and then we have an interconversion of electrical energy. Okay, so this we can see, okay, in our household appliances. Okay, like a ceiling fan we have, the motor we have, the grinders we have, or mixers. Okay, so like when you plug the ceiling fan, when you switch on the ceiling fan, okay, it starts to rotate. That rotation energy is the mechanical energy. Okay, what we are giving to the fan is the input energy, is the electrical energy. Similarly, we have interconversion of chemical energy. So this we all know that, okay, when you fire the wood which is dry, okay, it starts to burn. So that means the energy, the chemical energy which is stored inside this wood, okay, is converted into the heat energy. Okay, in the old in the village side, okay, so they use the wood as a primary source of energy for cooking the food. That means they are taking the wood, the chemical energy which is stored in the wood, and then they are burning that, and then the energy which is released, that heat energy, is used to cook the food. And then interconversion of heat energy, and then diesel engines. What happens in the diesel engines? Again, we have a petrol and diesel as the fuels, and then we burn them. We while burning, okay, the chemical energy which is stored in them is converted into the other forms of energy. Like in automobiles, it is a mechanical energy. Okay, interconversion of light energy. Okay, so what we have, the sun is the primary source of energy. Okay, so that energy from the sun, okay, when it is tapped in the photovoltaic cells, that can be converted into the heat energy as well as the light energy. Okay, so this gives a clear idea that, okay, energy can be converted from one form to the other form. Okay, so it cannot be created or not be destroyed. Okay, so then after discussing about energy and its forms and energy and conversion, and then we will move on to the classification of energy resources. Okay, so basically energy resources are classified based on, okay, like this, okay, renewable energy sources, okay, so and non-renewable energy sources. What do you mean by the renewable energy sources? The energy resources produced continuously and they are not inexhaustible. Okay, they are not going to deplete. Okay, so they are produced continuously, so they are not going to deplete in a shorter span of time, at least for the generation of the humankind. Okay, so some of the example for them are solar energy and wind energy, tidal energy and hydel energy. Okay, as long as the sun exists, okay, all these forms of energy are going to be there on the face of the earth. Okay, so these are called as the renewable energy sources. And then we have the non-renewable energy sources. What do you mean by the non-renewable energy sources? Okay, so they are going to exhaust quickly. Okay, if you continue using them, they are going to exhaust or deplete, or they are going to end, okay, at certain point of time in the future. Okay, so and then over the ages, some of the example are coal, petroleum, and natural gas. Okay, so these are found with like under this beneath the surface of the earth. Okay, so if you are go on digging this coal and then petroleum, natural gases. Okay, so one day or the other day, okay, for our future generations, okay, you might say that we are going to end with we are no more having a coal, petroleum, or natural gases. Okay, they are going to end. Okay, if you continue using them. Those are the two types of energy resources. Okay. So let us discuss about what are the differences between the renewable and non-renewable energy sources. Okay, renewable energy sources are inexhaustible, and then non-renewable energy sources are exhaustible. Okay, inexhaustible means they are not going to end. Okay, they will be continue to give the energy. Okay, and exhaustible means they are going to end at certain point of time in the future. Okay, so and then available freely and abundantly. For example, if you take the solar energy, it is available, okay, everywhere on the face of the earth. Okay, for example, in India, it is like more of this solar energy is available. Okay, so and then it is abundant in nature. Okay, so and it is non-renewable energy sources are not abundantly available. Okay, for example, coal or petroleum. Okay, it is limited resources. Okay, so if you keep on using them, they are going to end at some time. So and then initial and maintenance cost is high. For the renewable energy sources. Okay, for example, if you take the idle energy or the solar energy, for example, so installation cost and maintenance cost, if you want to use the energy from the water, you have to construct a reservoir, and then you have to build this energy conversion system, turbines, motor pumps, and etc. So that will cost you more. Okay, and then you have to maintain them also, so that will cost you more. Okay, whereas initial and maintenance cost is very less in the case of a non-renewable energy resources. And these are eco-friendly. Eco-friendly means if I burn the fuel, for example, wood or the coal, okay, it releases some of the harmful gases, for example, carbon dioxide, carbon monoxide, sulfur, etc. Okay, so those are harmful to the atmosphere or the ecosystem. Okay, they are going to cause like a depletion in the ozone layer or global warming, etc. Okay, so these energy resources, renewable resources, are eco-friendly. Okay, if you use the solar system, you are not having any byproduct after conversion of the energy, whereas in this case, if you burn the coal, okay, it will release the carbon dioxide into the atmosphere. That will affect the atmosphere. That is not eco-friendly. And some of the examples are solar and wind energy, and example for these are coal, petroleum, and etc.